Getting a good return on our investment is something that we all look for. And so in today's video, we explore that concept of maximizing our return by building a full gRPC service, and then through the use of JSON transcoding, converting it very quickly and easily into a REST API. Well, hello, wherever you are, whenever you are. Where am I? Melbourne, Australia. And when is it? It's August 2023. So yeah, as I said in today's video, really we're looking at two things. First thing we're going to explore is building a full gRPC service. So create, read, update, and delete actions, as you would typically expect. And then the second thing we're really looking at, which was a new feature introduced with .NET 7, is something called JSON transcoding. And what is JSON transcoding? Well, in a nutshell, it allows us to take gRPC service that we build in the first section and annotate those procedures or those methods so that we can use it as a REST-based API. And you might be going, why would we want to do that? We've already built a gRPC service. Why do we need to convert it to a REST service? Well, quite simply, web-based applications cannot, at the moment anyway, natively call gRPC endpoints. There are a couple of ways you can get around that. One is by using a proxy, which we're not doing today, and the other one is to do something like JSON transcoding, where you, I'm going to say, convert it into something that can handle native web requests over HTTP1. So that's what we're doing today. I actually think it's a really interesting feature, and hopefully you agree with me on that. So as usual, code is on GitHub. Let's not waste any more time and get started. So I've just got two slides to go through before we start coding. The first one is just around gRPC, what it is and why you would choose to use it. So it stands for Google Remote Procedure Call, so originally developed by Google, but it's now been open sourced, and yes, it is a remote procedure call framework. It uses the HTTP2 protocol to transport binary messages between endpoints, so that makes it super fast. It's focused on high performance, and chances are if you're using gRPC, that's the main reason why you chose to use it. It relies on something called protocol buffers or protobuf to define the contract between endpoints, and in today's video we're going to define our own protobuf file that contains the contract, if you like, that will be enforced between the server and the client, and it really contains the 5 method signatures that a client can use to call a server. It has multi-language support, so a client written in C# can call a service written in Ruby and vice versa. But in today's video, we're of course building our service in C#, and the client, we're just going to use Postman, okay? And we'll use Postman to ingest our protobuf file so it can see the contract that it can use to call our C# service. It's frequently used as a method of service-to-service communication, so you will find it in a microservices architecture, for example. But from a client perspective, specifically a browser-based app, I'm thinking in here, at the moment, those types of apps cannot natively call a gRPC service, basically due to the complex use of HTTP2. So the way around that would be to use a proxy, or as we're going to use today, JSON transcoding, which effectively turns our gRPC service into a REST-based API that could be used by a web-based application. Just an important point in that though, just because we're using JSON transcoding and in effect turning our service into a REST-based service, that doesn't mean to say that you lose the gRPC functionality as well. You still have access to that. So you effectively have one service and 2 ways to call it, which is actually a very cool feature in my view. There's just a quick schematic of what we've already discussed. We've got a JavaScript client calling a C# service. You can see the protobuf file exists on both endpoints because we need to define the contract somehow, and yeah, you can see it's communicating over HTTP2. Last slide, and it's just really to remind you of the ways you can watch my content now and going forward. So YouTube, of course, at YouTube/BinaryThistle, always free for everyone, forever, but you will have to watch some advertisements. Alternatively, you can check me out over on Patreon at patreon.com/BinaryThistle. That's a subscription model, so you pay a small monthly subscription, you get access to all my videos with no advertisements. And then finally, there's Jackson.net. That's a pay-per-video approach. So you pay for one video, you pay for 2 videos, but you keep them forever. There's no subscription and, of course, no advertisements. So with that, I think we're ready to start coding. So let's get started and scaffold up our gRPC service. So at a command prompt, let's check to see what version of the .NET framework we have installed. So that's .NET -- version. And as you can see there, I have version 7 installed. And if you want to follow along with the JSON transcoding element of the video, which we'll be doing a bit later, you will need version 7, as that's when that feature was introduced to the framework. Okay, so next thing I want to do is to change into my working directory, and I just happen to have the path, if I can type it correctly, stored in an environment variable, just because it's a rather long and unwieldy path. Quick check of, yep, I want to go into the code folder. And quick check again, yep, so I've got some prep code. So I actually want to create my project here, clear the screen to make it look a bit nicer, and it's just a .NET new gRPC for the gRPC template, -o, and we want to call it to do gRPC. And that will go away and scaffold that up for us. Quick directory listing, and we'll change into that directory. And then we will open it with VS Code, which as usual starts on my other screen. So I'll pull that on and get rid of my command prompt. Let's make that a bit bigger. Okay, and this has just created a very simple gRPC service for us. If you get this pop up, just click yes. And yeah, so we have a very simple gRPC service already defined. Now the first thing I want to do is come into the properties folder, come into launch settings JSON, and we have 2 profiles here. I want to get rid of this HTTP profile. So I'm just going to delete that, leaving us only HTTPS. So let's save that off. Maybe we take that line out. Doesn't make any difference functionally, but it just looks a bit nicer. Okay, so launch settings JSON updated. Now if we take a little tour of our service, let's look at the protos folder. And what you'll find in here is a protobuf definition. Okay, and it's very simple in this particular case. It's just defining a method called sayHello. And it takes in a hello request message defined down here, and it replies with a hello, or responds more correctly with a hello reply message defined down here. And in both cases, each of these messages just has one property, name, okay, a string called name. This number here just denotes the position of the property. And when we come on to defining our own protobuf file in the next section with create, read, update, and delete methods, you'll see some slightly more complex messages, and that concept of numbering will embed a bit more. Okay, but in this instance, it's really super simple. The other thing to bear in mind about this proto file is that it's really just a interface definition. Okay, it doesn't actually implement anything. It's really just telling you as a consumer of this service what is available to you. So I often think of it just like a C# interface. So you define your interface, but you actually have to implement the interface somewhere else in code. Okay, so that's how I kind of think of it. Which brings us nicely onto our services folder, and that actually contains the greeter service class, which implements the greeter service. So you can see here, it actually uses this greeter base class here, and here it's implementing the actual sayHello method that we had defined in our greet proto file. And all it does is it takes in the name from the hello request message, and it just responds with that name plus the word hello. Okay, so it's super simple, but it's useful because it gets us to test that everything is working. Now, how does all this work? How does defining a proto file like this, how does it allow you to then implement greeter base? Where do these classes hello request come from? We're not defining those anywhere, or it certainly doesn't appear that we're defining hello request and hello reply anywhere other than in the greet proto file. And again, this is not C# code, this is just a protobuf file. How that actually works is if we come into the CS_proj file, you can see we have a reference to that protobuf file, greet proto. And what happens when you build your project is those classes here, the greeter base class, the hello request and the hello reply class, they actually get built for you, okay? So it's very important anytime you change your proto file, if you want to have those changes cascade down into your C# code, you have to rebuild your project in order for those changes to manifest, okay? And the way you do that is by linking to it in the CS_proj file. And then the other thing, just to make note of, that this is defined as a server rather than a client, okay? So it's telling us that, yep, this is serving up those remote procedure call methods. So what we'll do in this section is we'll just quickly run up our service and test it in Postman. So control backtick to bring up an integrated terminal, and .NET, not .NET run. And that should start on two endpoints, one for HTTPS and one for HTTP. So I'm just going to copy that. And then I'm going to bring Postman onto the screen and just maximize that. So I've got collection selected. I'm going to select new. I'm going to create a gRPC request. We'll paste in our endpoint, but take out the HTTPS prefix. Okay, you'll get issues if you don't do that. And the other thing that caught me out was you need to enable TLS, okay, because again, we're using a secure endpoint. Now, ideally, what you'd like to be able to do now is to select the say hello method from our drop down here, but we can't do that because Postman is completely unaware of our gRPC service. So what we need to do is import the proto file so it has an idea of the definition of the services that it can call or the endpoints that it can call. So click on import a proto file, and I've already kind of navigated previously to my project location. I've gone into the protos folder, and here is the Greet proto file, and that's just exactly the same file that we have in our VS Code project. So click on that, click open. So click next. And what I want to do is in the drop down, I want to type in the name of this particular service. And I've personally found this a little bit again unintuitive. I'm going to call it Greet, and then I'm going to click on that, and then we'll import it as an API. So we now have our protobuf definition within our Postman environment. Okay, and if you come over to APIs over here, you'll actually see that listed here, and you'll see the definitions here. Okay, so that's where that sits within service definitions. So now if we click on our down arrow, you will see that we have this say hello method. Okay, fantastic. And then the only other thing we need to do is define the message, and you just define that as JSON. So curly brackets, double quotes, name, colon, and then I'll be a little bit conceited and I'll use my own name. And then if we hit invoke, it should respond back with hello Les. There we go. So a very, very simple service, but it gets us up and running. We know it's all working. We know Postman's working, so it means we can move on to the next section. So what we'll do now, just to finish off our setup, let's get rid of Postman for the minute. Let's kill this for the second. Let's take that down. What we want to do is just add some package dependencies into our project. So leaving the to-do gRPC CS_proj file open, we'll actually open our command prompt back up because we're going to add some packages, clear that down. Let's move this up a little bit. And again, I've said this a million times in my videos, the reason I like to have the CS_proj file open is so I can see the package references being added. You don't need to have it open, I just like doing that because I'm weird. Okay, so the first package we want is .NET, add package, and it's Entity Framework Core. We do need the design package, but the first one I'm going to add is SQLite. And as I'm sure as you know, that's just a very lightweight SQL database. Basically, it's just a file almost. You don't need to install anything particularly special to have it working. Okay, and you can see that package reference has been added. Clear the screen, up key, and we do actually need the design package as well because we're going to be migrating some stuff in a minute. Clear that down. .NET, add package. And the next one I want is the gRPC tools. Cool. And then the last one is .NET, add package, ASP, netcore, it's actually Microsoft, .asp netcore. I'm not having a lot of trouble with my spelling today. Let me try that one more time. Microsoft.ASP netcore, that's the one. It's already stored in the cache, so saves me typing. It's Microsoft.ASP netcore.grpc.JSON transcoding, and that's the, no surprises, the JSON transcoding stuff we'll be doing a little bit later. Cool, so clear the screen, get rid of that. So what we'll do next is we'll create a very simple model class, and we'll use Entity Framework Core along with a DB context to migrate that model down to our SQLite database. So we have a persistence layer, a very simple persistence layer, but we'll do that next. So back over in our project, right click in the File Explorer, new folder, going to call this models. Into our models folder, I'm going to create a model. So new file, I'm going to call this to do item.cs. We'll include the namespace, which is to do gRPC.models, and then it's just a public class called to do item. And a super simple class, so just a few properties. So prop, tab, first one does happen to be an integer, and it's going to be our database primary key. Cool, new line, prop, tab. This time it's going to be a string. We'll say it can be nullable, and then we're going to call that title. Excellent. Two more to go. Prop, tab, string again, can be nullable. We'll say description. And then the last one, prop, going to be a string. Call it to status, and this time we will actually assign it a value, a default value of new. So the idea is we'll create some to-do items, and when they get created they will have a status of new. Okay, fantastic. So let's save that off. Next we want to create a DB context, so right click, new folder, I'm going to call that data. Into our data folder, right click, new file, and we'll call that app.db context.cs. So very bog standard ASP.NET Core functionality. There's nothing too radical in here. So namespace to do gRPC.data. It's just a public class called app.db context, but it implements db context, and we'll need to bring in the namespace, so control period, to bring in using Microsoft Entity Framework Core. Curly brackets, and then we'll define our constructor, so ctor, tab, app.db context, and into this we're going to expect db context options. What's the type? The type is app.db context. And we'll call that options. And then we'll say that's from the base class, like so. Fantastic, we'll just leave that empty for now, we don't need to put anything in that at the moment, or at all in this project anyway. And then we just need to define our data set, which is basically our table, using our model. So let's use prop, tab over, what type is it? It's a type DB set, and the DB set is of type to do item, and we will need to bring that namespace in, but let's just finish this first. So that's a collection of to do items, and I'm going to change this slightly, and we'll say that goes to set to do item. I need to make sure I spell that correctly. Round brackets, semicolon, and we'll bring in the namespace for our model, and that's in to do gRPC models. Fantastic. Let's save that off. And then just to wire up our DB context for dependency injection, if we come over to the program class, I'm going to take out these comments. We don't need them. Take this out as well. And we're going to add a DB context to our service collection. So in here, builder, access or services collection. Going to add a DB context of what type? App.db context. Bring in the namespace for that. And then we'll just configure it. So we're using options, OPT goes to OPT. And we'll say use SQLite. Now I have a tendency to put in two L's there, even though that's completely incorrect. Let's just bring in a namespace for that. So control period to bring in Microsoft Entity Framework Core. Then in here, we're just putting our connection string. which is of the format, double quotes for the string, data source, and then you just give it a file name. And you can call this anything you like. So I'm just going to say to do database. It's not really like a conventional connection string where there's any dramatic security or anything. It's really just a file. So that should be our DB context wired up. So to test that, let's generate some migrations. So control backtick to bring up a command prompt once again, and we're going to use the EF core toolset. So .NET EF migrations add, and let's just say initial migration. Let's generate our migrations. Okay, cool. We have our migrations folder now, as you can see here. And if you take a quick look at this, it's just fairly simple stuff. You can see it's setting up a table named to do items. Okay, and yeah, pretty straightforward. So we want to migrate that down to our database yet. Now, let me just minimize this stuff. What we'll do, we'll actually create a database file in our project. You can see that's not there yet. All we've got is our migrations. So we actually want to, yeah, as I say, update our database and, you know, run our migrations. So .NET EF database update. That looks pretty good. And you can see we have our to-do database.db file here. And then you don't need to do this, entirely optional, but I like using this tool dbeaver just to kind of poke around the database and have a look and see what's happening with it. And it's also useful for debugging. So I'm going to create a connection to our SQLite database. Next, and then you just specify the file path. And yeah, that looks like that's pointing to the right location. So to do database, let's open that up. And let's finish that. Okay, and this is the community edition I'm using, which is free. So let's expand this. Let's expand tables, and you can see here there's actually two tables. One that Entity Framework creates that just has no surprises, the migrations history in there, and we have one that represents our to-do items. Okay, so we can do actually have to select the database and do new SQL script, and we'll just do a select everything from to-do items, and we'll just run that. So it's control and enter, and we have our table here, so an ID, title, description, and to-do status columns, but there's no data in there. All right. So that brings us to the end of the generic part of the setup. We've established our service structure and we've set up our persistence layer. Next, we'll come on and define our own protobuf file. So let's just minimize dbeaver and come back into our project and get rid of the command prompt. And yeah, as I said, what we're going to do is we're going to define our own protobuf file. Okay, so let's right-click protos, new file, and we'll call this to.proto, like so. And just before we go on, if we come back into the Greek proto file, you can see that we have these three declarations up here. I'm just going to copy those because they're pretty much exactly the same. So saves me typing and put them into our to-do proto file. So the syntax is just the version of the syntax being used. The next one is the namespace of our application, which is fairly straightforward. And then we do need to give our package a name. So I'm going to call this to do it. Okay. And as per a standard CRUD paradigm, we're going to have 5 endpoints. So create endpoint, a read single item endpoint, read list endpoint, an update endpoint, and delete endpoint. Now, these are all going to appear in our service. So we have to wrap all of these in the service. And by the way, these are just comments, just placeholder comments for us to manage our project. So just bear that in mind. So this is all in a service. So let's wrap it in some curly brackets like that. And we do need to give our service a name. So to do it. Okay, and just on the kind of syntax highlighting, it's actually quite useful. You don't get that out the box with VS Code. Like most languages, you have to install plugins to get the syntax highlighting. So the one I'm using, if we come over to extensions, is just this one here, VS Code protobuf 3. I've not had any problems with it. It seems pretty good. You might want to find your own one, but I would suggest if you're working with proto files, if you're anything like me, you're going to make a lot of syntactical mistakes. So syntax highlighting is actually really useful. Okay, so just to recap, we're specifying our method endpoints in a service. But before we do that, I want to define the messages that each of these services or each of these endpoints will take. And the way we do that is just by specifying a message, give it a name. So let's start with our create endpoint. So we'll say create to do, and this is the request. So what we're passing over, curly brackets, and then you specify the data type. So we're going to pass over the string called title, and we'll put that in position 1. And the other thing we'll pass over is the description, and we'll put that in position 2. Okay, and if we come back to our model, that should marry up quite closely. So again, we're not going to pass the ID because the database will take care of that for us when we create it. Title and description will pass over. We're not going to pass over the status when we create a new item because we do that already. When we come to doing the update stuff, we will allow you to pass the status over at that point. Okay, so fairly simple. Next one we'll do is the create to do response. And I'm just going to return the ID of the object that was created. Put that in position 1. Now you could of course specify all the attributes here, all the properties here if you wanted to make it a little bit more like REST, but I'm just going to keep it simple. Coming back up here, let's define our method. So RPC, give it a name, create to do. What does it accept? It accepts a create to do request. And what does it return? It returns a create to do response. And just a pair of empty curly brackets for the moment. That will get populated a bit later when we do the JSON transcoding stuff. But that's basically our first method defined along with its messages. So I'll save that off. I'm going to do these next two. I'm going to type these next two out. The other two, I'm just going to cut and paste those in, but there's a couple of sort of novel things in here that I want to go through. So let's do our read single stuff. So we'll define the messages. Let me just move this up a little bit. So message, read to do request, and we're just going to pass over the ID. Okay, so it's sort of similar to REST in that respect. Give us a resource, here's the ID of the resource, that's all we're going to pass over. For the response, say read to do response, we are actually going to return everything. So I'm just going to copy this, trying to save on typing, paste those in here, take a new line, we're going to return the ID as well. So put that in here, and we will need to change the attributes for title and description. And then we are also going to return the status. So it's to do status in position 4. And you'll notice I'm using, I think this is called snake case, as opposed to, I think this is Pascal case, and this is snake case. So when you're defining protobuf files, this is how you name your properties. Okay, so you can check out the Google documentation on that, as Google actually came up with the gRPC spec. Cool, so that's our, which we have to do the method definition. So again, it's very simple, it's very repetitive in fact. We'll say read to do, and it accepts a read to do request, and it returns, you guessed it, a read to do response. Very, very straightforward. Last one I'm going to type out is the list, because there's a little bit of novelty there. So like with REST paradigm, when you're making a call to a list, you can supply some stuff in the query string to maybe filter it, but we're not going to do that. We're keeping it simple. We're just going to say, give us all the items that you have. And so we're not really passing anything over with it by way of like a parameter or anything like that. So, and we're returning, of course, a list of all our to-do items. So we can do a little bit of reuse here. We can kind of reuse this message here, but you'll see how we do it when we start defining the messages for that endpoint. So first one, message, I'm just going to call it get all request. Okay, and as I say, we're not passing anything over, so we just define it as empty. In terms of the response, I'm going to say get all response. And what we're going to do is we're going to make use of this message here. And the way we do that is by using the repeated keyword. Okay, repeated. What are we repeating? We're repeating the read. To do response, call underscore to do. I'll put it in the position of 1. So again, making use of this same data we want to return back, but just a list of it. So let's specify that method. So RPC, let's say list to do. What does it accept? Get all request, and it returns the get all response. You're getting it. I'm sure you're getting it. It's not that difficult, to be honest with you. And again, to labour the point, this is just an interface spec. There's no implementation here. So let's save that off. So in the interest of time, what I'm going to do, rather than typing out, I'm just going to copy over from my reference project. I'm just going to copy over the other messages to support our other 2 methods. So update to do request. So we're passing over the ID, because we'll need to actually retrieve an object based on its ID so we can update it, the title, the description, and we're passing over the to-do status. In terms of response, we're just passing back the ID, and then in terms of our delete, we are just passing over an ID and returning the ID of the resource that was deleted. Let's see if I can format this document. No. So I just want to tidy up the formatting here. That's a little bit annoying. So I think it's just these brackets. Again, makes no difference to the code, but it would just drive me a bit nutty if I left it like that. Okay, and last one there, and I'm just going to paste in the method declarations as well. And there's our delete, and do it the wrong way around, and let's do our update here as well. Okay, and these really should be indented as well. So that's our proto file finished for the moment. We will come back and revisit it when we do the stuff around JSON transcoding. Just one thing before we move on though, before we draw a line under the proto file, if we come back into our csproj file, you'll remember we have this directive here linking our Greek proto to our project. So we do need to do exactly the same thing for our to-do service. So to-do proto, and that's it basically, it's a server as well. Okay, so when we build our project, we will get C# classes defined based off of our to-do proto file that we can then use when we move on to the next section to define our service using C# code. So let's do that now. So yeah, we want to come on now and create our own service class, but just before we do that, one step that we need to perform is to build our project. And why do we want to build our project? Well, because we've included a reference to our protobuf file, when we build our project, we actually get some C# classes constructed for us, and we'll use those classes when we actually come on now to build our own service. Okay, so make sure you do that before you move on. So with it built successfully, we can close that down, come over to our services folder, right click, new file, and we'll call this to-do service.cs. And I'm just going to close down the side panel just to give us a little more room. So namespace, to-do gRPC services, and then it's just a public class called to-do service. And it's going to implement to-do it, and this base class is what we want to implement. And again, we get this because we have just built our project. And just bringing this back up, coming over into the to-do proto file, just to remind you that is what we call the service here, okay? Cool, so curly brackets. Now we're going to implement our 5 methods, but what those 5 methods rely upon is access to our database. And in order to access our database, we need a DB context. So we're going to get a DB context through constructor dependency injection. So ctor tab to define our constructor, and we're going to pass in an app DB context. We'll call that DB context. Let's just bring in the namespace for that. And then we're going to assign this value, this DB context value, to a private read-only value called DB context, or underscore DB context. Okay. like that. And we just need to generate this now as well. So control period, and it's this one here, generate read-only field. So if you're a little confused by dependency injection and what I've just done there, don't worry. You can sign up for a free account on lesjackson.net and take the free dependency injection module that's part of the .NET Developer Toolkit course I have over there. And there's a number of other free modules that you can take as well. So if you're a bit interested in deep diving dependency injection, you should check that out. But hopefully you understand what's going on here. Because we've registered our DB context in our service collection, we can inject it through this constructor in this particular way. Excellent. So now what we're going to do is start defining our methods. And the first one I'm going to start with is the ability to create a to-do item. So let's get started. Public override async task. What type is the task returning? It's returning a create to-do response. And this, again, is another example of one of those classes that we get because we've built a project and added a reference to our proto file in the project file. I'm going to call it create to-do, and it accepts a create to-do request. We'll call that request. And also accepts a server call context, and we'll call that context. And this just allows us, let me just bring in the namespace first, control period. This just allows us to basically manage our call. So you can do things like cancel it and things like that if you so want to, but we're not really making use of it today, but it is a requirement of the method signature. So I want to do a little check on our request object. So if request title, so that's the title of our to-do item. If it's an empty string, or likewise with our description, then I'm saying that object that's been passed over is effectively invalid and we don't really want to do anything with it. So we're just going to throw the new RPC exception. And let's define the status of that. So new status, status code, and I'm going to say invalid argument, which I think makes sense. And then we can just give that argument something like you must supply a valid object. Okay, so this is somewhat analogous maybe to like a HTTP 400 type response, although it's not the same thing exactly, it's similar. Okay, so assuming we have a valid object, let's actually create one. So var to-do item, so we'll need to bring in the namespace for our models, equals new to-do item. And let's do that now, bring in the namespace, so models, and we're just going to assign values to this. So title equals request title, and description, I've got an equivalency in there, not a assignment, so that's better. Description equals request description. And now this is a little clunky, actually assigning creating objects in this way. I'd probably recommend in a more production type environment you use like a mapping framework, something like Automapper for example. And again, over in the .NET Developer Toolkit course, I actually do have a module on Automapper and DTOs that goes into this in more detail. But again, because this is a small object, I think it's okay to do it in this way. So with our object created, all we need to do is just add it to our database. So we're going to await on our DB context, and we're going to add async our to-do item. Oh, and the other thing I forgot to mention, it's probably an obvious one, we don't define the state here because we are auto-assigning the status of new, and we don't have to define an ID because the database does that for us. So from a creation perspective, we just need these two attributes here. Now again, this is standard Entity Framework core stuff, but if you don't save your changes, then the fact that you've added this item to your DB context makes no difference. It won't actually get persisted down to the data layer. So you need to save changes async in order for that to actually happen. And then we want to return a result. So return await on task, and from result, new create to do response. And this is just the ID of the new object that we have created. So if we make that equal to our to-do item ID, we will have an ID at this point because we've been assigned one by Entity Framework Core, or more correctly by our SQLite database, and we don't need a semicolon there. All right, so that is looking pretty good. Let's save that off and let's run it up. So .NET run. Actually, before we do that, I always forget this step. Just before we do that, what we need to do, we bring our sidebar back up, we come into program class, and we actually need to register our service. I always forget to do that and always get errors, so thankfully this time I remembered. So in here, to do service, like that. Okay, that's better. So we can now run it up and we can make an attempt to call our create endpoint. So .NET run, not rub, run. So let's bring Postman up and we're going to make a new request to our create endpoint. So new gRPC, I need to enter the URL, so just copy up to localhost, paste it back in. Don't forget to enable TLS. And then if we come over to our method definitions, we can choose to use the greet definition we created in the introduction, or we can import a new file. And I'm going to do that, so select our to-do proto file and open that. Fantastic, click next, and type in the name of our new API. So I'm going to call this to-do service, and we'll import that. And you see that over here in the API collection, and also when we click on our method selection, you can see we get all 5 methods, and that's because all 5 methods are defined in the proto file, but they're not all implemented. So if we pick one of the unimplemented ones, like list to do, and invoke it, we get an unimplemented result, which makes sense. So let's pick our create method and we'll define a message. So let's give it a title and we'll say finish other endpoints. And let's just test that without a description. We should get an error. And we do, we get an invalid argument, so you must supply a valid object, so that's looking pretty good. So if we then supply a description, we need to make sure we spell it correctly, or I spell it correctly. Let's just say remaining 4. And invoke that. We should get an ID back of our resource, and we get an ID of 1, so that's looking pretty good. Right, so let's move on to our next endpoint. So let's go on and introduce another endpoint method. So get rid of that, come back into our project, into our service class, to do service. And the one we'll do next is reading a individual to-do item. So let me just get my cursor in the right place. So that's public override async, and you'll start to see a pattern emerge here. Task, read to response, and we'll call this method read to do. Let me get rid of this so I get a bit more room, and it accepts a read to do request. Call it request as usual, and again accepts a server call context, and we'll call that context. So I just want to do a little bit of validation. I just want to check that the ID is non-zero. Might still not return a response to us, but I just want to do that anyway. So it's less than or equal to 0, because we're not going to get an index from our database that's less than or equal to 0. Then we're just going to throw an exception. So throw new RPC exception, and it's a new status code, and this is the same one we've used before, invalid argument. And we'll give it something a bit more specific. Resource index must be greater than 0. Cool. All right. So having performed a little bit of validation, let's attempt to get an item back from the database. So we'll declare a variable called toDoItem. We'll then await on our DB context. toDoItems collection, we'll use first or default, and we'll say t goes to t ID, equivalent to the request ID that's passed in. There we go. Oh, and I need to use the async method of this as we're waiting on it. That's why it's erroring out. And that requires entity framework core. All right, that's looking pretty good to me. So we'll then just do a little check on the toDoItem to make sure it's not null. So if it's not null, then we have something, and we'll return back with that value. From result, and we'll create a new to-do response. And this time we're going to pass back everything. So we'll pass back the ID, which will be the toDoItems ID. Pass back the title. And again, as I've already mentioned, AutoMapper or something like that would be a good tool to use here, a good framework to use here, as it would save you doing all this sort of manual assignment. But this is, I think, the most properties we're going to be assigning, so 4 is not too bad, but it's on the cusp of what I would say was acceptable before you started using a framework. And again, I do have a module in the .NET Developer Toolkit course that goes through object mapping and data transfer objects. Cool, so that's what we do if it's valid, and then if it's not valid, then we'll throw a new exception. So new, I keep wanting to say RCP, I have no idea, RPC exception, and new status. And this time, the status code we want will be not found. So that's, again, analogous to the HTTP 404 that you would get in a REST-based API. So we'll just say no task with ID. And using string interpolation, we'll just use our request again and pass through whatever the ID was. Okay. So our first validation check is just checking to see that it's greater than 0. Still no guarantee we'll get a hit. And this one is really just saying, yeah, you passed in a positive integer, but there was no resource found. So we can save that off, and let's run up our code. Stop that from running from last time, and we'll do a .NET run. Fantastic. Let's bring up Postman, and go into our drop down, and we will get our read to do action. And so we'll change our message to ID, and we'll make that equal to, that's an integer, so we don't put it in quotes, so we'll make it equal to 1, and we should get back the object that we've just created. Indeed we do, so that's looking pretty good. If we put in 0, yep, invalid argument, so index must be greater than 0, so that's looking pretty good. Now if we put in something that is a valid ID, but doesn't relate to any task, we get our could not find the entity response. So I think that's looking pretty good. So let's move on. Now I did debate at this point whether to just cut and paste in the remaining actions. And for those of you who've watched my other videos, you know I never do that. And I'm going to hold true to that, and I'm not going to cut and paste code. So I'm going to type out the remaining 3 methods as well. And if you know that's a bit laborious for you, then obviously feel free to fast forward the video. The time codes are also in the video, certainly on YouTube. I put the time codes below so you can skip ahead to the next section where we look at the JSON transcoding stuff. But I'm going to continue with writing the methods out. So next one we're going to do is the list method. And to make sure I'm in the right place, let me just move my code window up a little bit. So again, public override async task turns a get all response. Whoop. like so. We'll call this list to do, and it accepts a get all request. Call that request, and a server call context. Or context. Declare a variable for our response object that we're going to pass back. So even if it's null, we still want to pass it back. So that's just a new get all request, or sorry, get all response object. We'll populate that a bit later. Next, we want to actually attempt to get the to-do items from the database. So we'll declare another variable called to-do items, and we'll make that equal to db context to-do items to list async, like that. Okay, now this could be null. To-do items could have nothing. They might not have anything in there. So irrespective, we're going to loop round our collection. So we'll create a object called to do, look in our to-do items, and then as before, we're just going to assign our object manually. So we'll say response to do, add a new read to do response. And we'll put a semicolon there. And now I might actually copy this code here just to save me typing it, because it's a little bit laborious. And we need to change this though. All right, cool. And then we just return that. And of course, this response object, get all response, could be null, or it could have items in it. It doesn't really matter. And we'll just return a response like so. Okay, save that off, rerun our code. Let's test it in Postman. So what I might do is I might add another item. And we don't really need to test it, but I might just do it anyway. So we have a couple in there, just so we can see it's iterated round. So title is finish update endpoint. And description is update endpoint. And we'll invoke that. Cool. And then if we come down to here and do our list to do's, we don't need a message, so take that out and invoke that. We get our collection of items back. So again, that's looking pretty good. So two more to do. Let's do our update one next. And again, these are all just variations on a theme now, to be honest with you. So let's come over here. Let's do an update. So public override async task update to do response. We'll call this update to do. And it accepts an update to do request called request, and a server call context, which should come as no surprises to you. So again, as before, we'll do a little bit of validation just to make sure that what's being passed through is somewhat relevant. So request object let's look at our ID. We'll do the same check that we did in our last endpoint and just check that the index is not less than or equal to 0. And then again, I might do a little bit of cutting and pasting from our create endpoint and just copy this clause as well, or these clauses as well. So don't forget to put our OR in, and we'll do that check. Okay, so we're just checking the ID, the title, and the description. And again, I did say I wasn't going to copy and paste code, but you've already seen me type this, so I think I can give myself a pass on that. I'm going to copy this and say must supply a valid object as our exception. And I keep wanting to type RPC exception as RCP exception for some reason, so let's leave it at that. So what we want to attempt to do then is retrieve our object that we want to update. We want to retrieve that from the database. So let's create a placeholder for that. And we'll await on our DB context to do items, first to default, In fact, I could copy this as well. I might just do that from our read method up here. Just copy this, because it's pretty much exactly the same. I'll keep my code consistent. Okay, so we'll attempt to get our item. We'll do a quick check. So if the to-do item is null, i.e. we don't have a hit, then there's nothing to update. So we'll throw a new RPC exception, new status, and the status code is not found. So again, like a 404 response, and I could have copied that from upstairs as well, but let me just type it out. So no task with ID, string interpolation, request. A little bit of C#, not C#, a little bit of JavaScript kind of creeping in there. Sort of, not quite, but sort of, okay. And that's cool. And then this is sort of going to be analogous to a REST-based put request where we just update the whole object as opposed to a patch request, which patching allows you to update just specific elements in an object. Put request generally updates the whole object. We're going to take the put kind of approach and just update everything. So again, this is something where you would typically use a mapping framework to do this for you, and you wouldn't have to do what I'm about to do now, which is map everything through. So we'll say the title equals the request title, whatever the value happens to be in there. We'll say the description, likewise, the request description. And this time, we're going to allow the status to be updated. So the whole point of updating your to-do items is to, I guess, go through some kind of state transition and say it's no longer new, it's in process, or it's paused or something, cancelled. So we will allow, yep, that was right, to pass over the status. All we then need to do is just save that back to our DB using save changes async, like so. So we've retrieved our object from our context, we've now updated it, we've just saved it. Okay, and then as per our proto file, all we want to do is just return the ID of the updated object. Update to do response. And again, if you wanted to, you could absolutely return the whole object back if you liked. Entirely up to you. You can maybe do that offline at some other point. So to do the item ID dot ID, not comma ID. And I'm missing my equals sign there. Okay, looking good. Don't need a semicolon there, I keep doing that. Okay, cool. So no semicolon at the end of our assignment there. So let's just run it up. .NET run. And bring Postman back onto the screen as well. And what I'm going to do is I'm going to copy this object here, our update endpoint to do item, because we have finished it. Well, we're testing it, so maybe let's update that to reflect that. So over in our drop down, let's select our update endpoint. Let's go over to message and let's paste in that object. And I'll leave the title description the same, but I'm going to put the status as in test. Okay, and let's invoke that. We get our ID back, so if we then use our other method, which is our, well, let's just use the list, we'll just bring back everything. You can see that we've updated our object, it's now in test. So I think with it being in test now, test's completed, it's looking pretty good, so we can say done. And we'll just select the right method again, let's invoke it, and yeah, we're done. So all that's left now is our delete endpoint. So our last endpoint, delete, is actually probably the simplest of all of them. So you could probably have a crack at writing this yourself, but I'll just do it anyway because I'm a nice guy. Override async, task of type delete to do response, and we'll call this delete to do. and it accepts a delete to do request. We'll call that request. Server call context. And we're just taking in an ID. So what I might do is for our read one, I'm going to do this little bit of checking here to make sure we pass through a positive integer. Throw an exception if not. Actually, we can probably copy some more stuff from that as well. Yeah, so let's copy this. So we're going to attempt to retrieve our item from our database. Do that as well. This is where it diverges slightly. So if the to-do item is null, then we'll throw a new RPC exception, new status, and this is again a sort of not found type status code of not found. Okay, and use string interpolation, we'll say no task with ID. Request ID. Otherwise, we've got our valid object, so all we want to do is use our DB context and use the remove method and remove our item like that. And of course, don't forget to save changes. Save changes async actually in this case. And then we did say that we will return the ID of our deleted object. So return await task from result new delete to do response. And we'll just say the ID is equal to our to-do item ID. Perfect. Save that off. We'll stop that from running and run it up once again. Bring Postman back onto the screen. Let's list our items. We still have 2, and I'm going to delete this one here, number 1. Okay. So come down to delete, and I just update this to number 1. And we'll invoke it. Looking good. And we'll list them all again. And we should only have 1 item there, which is in fact what we have. So that really brings us to the end of our section on building our pure gRPC service. Okay, it does create, read, update, delete operations. You could of course make it a bit more detailed and elaborate. What we're going to do now though is move on to the section on JSON transcoding, where we take our pure gRPC service and we allow users to call it from a web endpoint, and basically it's going to work effectively like a REST-based API. So you basically get 2 for 1. You'll still have your gRPC service that you can call using gRPC and HTTP2, and then you'll also have a service that you can call using a web front end. So let's start with that. So in order to enable JSON transcoding within our project, we need to first of all add 2 reference files, and those files are listed in this Microsoft document here. And so I'll put a link to this document in today's video as well. But if we just scroll down a little bit, it's these 2 files here, HTTP proto and annotations proto. Okay, and if you just follow these links, take you to a GitHub repository and you have those files here. Okay, so let's do that first of all. And that basically just introduces JSON transcoding support. Okay, so we're not going to look at those files in any great detail or do anything specifically with them. We just need to introduce them to our project. So over here in a project, you do need to put them in a very specific directory. So in the root of your project, create a new folder called Google. And inside the Google folder, new folder called API. And then 2 new files, new file, I'm going to call this one annotations.proto, and the other one is HTTP proto. Excellent. And I'm just going to copy and paste those files from the GitHub repository that I just showed you. Annotations proto, save it. And I'm not going to go through this in any detail at all, I'm just copying it over. And we'll save that off like that. Next thing you have to do, we've already done it actually, if you come into a project file, is include this package here, Microsoft ASP.NET Core gRPC transcoding, but we did that at the start of our project build, so you already have that. If you didn't do that though, just make sure you have it, and we're going to come on and use it now. Next thing to do then is to come into the program class, and where we have our services here at gRPC, we need to further define that as using JSON transcoding. So dot add JSON transcoding, and that basically means that JSON transcoding, no surprises, is in play now in addition to classic gRPC. So save that off as well. And then really the more interesting thing, that's really just the setup, that's the wiring up, if you like. What we then need to do is come into our proto file, or to do proto file, and we need to start annotating each one of our endpoint definitions to tell it essentially how we want it to behave as a HTTP endpoint. So let's get started with that. So to start annotating our endpoints, the first thing we need to do in our proto file is to include a reference to the annotations file we just created in the last section. And we do that just by an import statement and providing a path to where we can find that file. And that's at annotations.proto. And don't forget the semicolon. Now before we come on to actually doing the annotations, the other thing that I forgot to do in the last bit of setup was over in app settings JSON, I want to change this protocol from just being HTTP2 to allowing HTTP2 for our gRPC stuff, but also allowing the older HTTP protocol so that we can actually use web-based requests. And so I'm just going to update this to say HTTP1 and HTTP2. So again, that's a really important part of this. gRPC relies upon HTTP2 for the most part, but because we're introducing web-based traffic, we need to be able to use HTTP1 as well. All right, so with that little diversion over, we can now actually annotate our endpoints. First one I'm going to pick is this one here, the list to do endpoint. So fairly simple one, arguably the simplest endpoint we have. So inside the curly brackets, we come down and we specify an option, and we have to do this for every single one of our annotations. So it's fairly uninteresting, but absolutely critical. So it's just google.api.http. The real interesting stuff comes next. So set of curly brackets, semicolon. Do not forget that semicolon. You'll get a compile time error if you leave it out. And then we just define or annotate what this endpoint should do from a HTTP web request perspective. And first thing we specify is the verb that we want it to respond to. So standard REST stuff, this is going to be a GET-based request. And when we do our other endpoints, you'll see the other verbs that we will bring into play at that point in time. But for now, let's finish this one off. Next thing we specify, and the last thing we specify, in this example anyway, is just the route to where this endpoint can be found. So /, and then it can be really anything you like. So I'm going to say v1 for version 1 of our API, and this can be found at the to-do endpoint. Another very important point, do not forget the /. You'll get a compile time error if you leave that out as well. So let's save that off, and let's run it up to test it. So we're getting quite exciting. Cool, let's bring Postman back onto the screen. New request, HTTP request this time. Let me just get the endpoint. So this time we do want to include the HTTPS prefix, unlike with gRPC, so let's put that in here. We already have GET request selected by default, and we should be able to run this up. Indeed we do. So we now have a HTTP endpoint as well as a gRPC endpoint, which I actually think, I don't know about you, I think that is exceedingly cool thing to be able to have. I think it's really quite awesome. So let's just wrap this up and annotate the rest of our endpoints, and we'll do a quick bit of testing. So let's just finish off the rest of our annotation. So kill down Postman, stop this from running, and we'll come back into our proto file. So I'm just going to work top to bottom, and we'll start with our create to do endpoint. So as before, come in here, specify an option, and it's just google.api.http, and we make that equal to what verb would we expect in a REST API when we're creating a resource. That's correct, a post request. And the route is just going to be exactly the same, in fact, as our listing request, so v1 to do. The only slight difference, comma, is we want to specify an annotation for the body, and here I'm going to use a wildcard and say I just want everything from the body passed through to our request. I'm not going to test this just yet. I'm going to move through the rest of the endpoints. Again, good idea to have syntax highlighting for protobuf files installed, because you can see here this doesn't look quite right, and that's because I forgot the semicolon here. So I do suggest you install some form of syntax highlighting, because protobuf files can get a little bit tricky, especially when you're as bad a typist as I am. So next one we're going to do is reading a single line. So again, option, Google, API, HTTP, equals, again, it's going to be a GET request. A little bit more interesting this time, /v1 /to do. But this time we can actually have a variable in here saying that we expect an ID to be passed through in the route. Again, standard REST practice. Don't forget the semicolon there. Our list one has already been defined, so we come on to our update. So in here, specify an option, Google API, HTTP, equals curly brackets. I'll put the semicolon in to start with. Standard REST, we're just going to make this a put request, and the route is going to be /v1 /to do. Now, in most REST-based APIs, you would probably have an ID in here, denoting the resource ID, certainly the ones I've seen. I'm not doing that today because we're actually getting the ID in the body payload, which brings us nicely on to specifying the rule for the body in this case. And again, likewise with create, we just want everything passed through. Cool, and then that brings us on to our last annotation, delete. Should be getting the hang of this by now. Option, Google, API, HTTP, equals, no surprises, delete. And then just a route, so /v1 /to do, and again we are going to expect an ID pass through in the route like that. Don't forget the semicolon. Okay, I think that's everything done. We'll find out if we made any mistakes. We'll do a .NET run. Looking good, and let's come back to Postman. So let's just create a new HTTP request for our creation endpoint. So select post. I'm just going to come back here, copy this route, and paste that in like so. And then come over to our body, and we will define our body. So it's raw, JSON, and then let's create a new to-do item. So we'll say title, complete testing, and let's not pass over the description and see what we get. So we get a 404, not a 404, we get a 400 bad request, which is exactly what we'd expect, and we get our validation message here, which is excellent. Okay, so let's rectify that. Description, just say all endpoints. That should be good enough, so click send. Excellent, we get a new to-do item created with an ID of 5. Let's come back to gRPC. Let's make a call. Yeah, let's list everything. That's good enough, and we can see that we can use gRPC, we can use our HTTP stuff, and we have our new endpoint here. Excellent. So let's see if we can update this. So let's just copy this payload, and we'll come back to here. Let's just update this to be a put request. Let's change the body payload to something like this, and we will say that the testing is now in progress, like that. Hit send. We get an ID back. Let's test the retrieval of our individual endpoint. So that was ID 5. Send. We get that. We get in progress. This is looking really good. Let's pass over an ID that we know we don't have. Excellent. We get 404 not found. And then what's the last one? Well, I think we're basically finished testing. We've tested them all, create, update, list, get an individual item. So all that's left is delete. So let's delete this one here. Oh, update that. Well, again, that's working, 404. That's cool. Let's put delete. Let's put ID 5 in. That's what I meant to do in the first place. So cool. And let's see if we can pull that back. No task with ID of 5. Fantastic. So that really brings us to the end of the video. I don't know about you, but I think that's really cool. You've got a gRPC service that you can use for service-to-service communication and all the benefits of the speed that come with gRPC, but you could also expose that service to a web-based client without having to do too much work. You saw how easy it was to annotate those gRPC endpoints. So don't know about you, but I actually really, really love this feature. I think it's great. I'm going to use it. I know I'm going to use it in my own projects, but as usual, be really interested to find out if you feel the same way. Please put your comments in the section below. So until the next time I see you and make my next video, stay very safe and hopefully see you again very soon.